In this video, we're going to talk about how to integrate functions that lead to inverse trig functions. Now, there's three formulas you need to know. The first one, the antiderivative of du divided by the square root of a squared minus u squared. This is equal to arcsine u over a plus c. So that's the first equation you want to know. The next one looks like this. The integration of du divided by a squared plus u squared. This is equal to 1 over a arctan or inverse tangent u over a plus c. And there's one more. Integration of du divided by u times the square root of u squared minus a squared. That's equal to 1 over a arcsecant u over a plus c. So make sure you write down these three formulas because we're going to use them a lot in this video. So let's start with this example. What is the antiderivative of dx divided by the square root of 16 minus x squared? So what do you think we should do? Well, first, we need to identify the values of a and u. U squared is x squared, which means that u is equal to x if you square root both sides. And then du is equal to dx. A squared is 16, and the square root of 16 is 4, so a is 4. Now what I'm going to do is replace dx with du since they're equal to each other. And then I'm going to replace 16 with a squared and x squared with u squared. Now you've seen this formula. This is the arcsine formula. It's arcsine u over a plus c. Now all you need to do is substitute u and a into this equation, and you're going to get the answer. So the answer is arcsine x divided by 4 plus c. And that's it. That's how you can use the formula to integrate this function. Let's work on another example. What about the antiderivative of 3 over 25 plus x squared dx? So feel free to pause the video and try this example. So u squared is going to be equal to x squared, which means u is x and du will be equal to dx. A squared is 25, which means a is the square root of 25, or 5. So what I'm going to do is move the 3 to the front, replace the dx with du, replace 25 with a squared, and replace x squared with u squared. So here's another formula that we know. The antiderivative of du over a squared plus u squared, that's 1 over a arctan u over a plus c. Now, we have the constant in front, so we got to multiply this by 3. Next, let's replace a with 5 and u with x. So it's going to be 3 over 5 arctan u over a, or x over 5, plus c. And so that's the solution for this problem. Let's try this one. 8 over x times the square root of 4x squared minus 1 dx. So how should we begin? We'll notice that this setup is similar to the setup for the Arcsecant formula, which is it has the square root u squared minus a squared. So we could see that u squared is 4x squared, and the square root of 4 is 2. The square root of x squared is x, so u is 2x. du is 2 times dx. So in this problem, we need to solve for dx. So it's going to be du over 2. Now we can see that a squared will be equal to 1, and therefore a is 1 because the square root of 1 is 1. So now what we're going to do is move the constant to the front. So there's going to be a 1 on top. We're going to replace 4x squared with u squared and 1 with a squared. Now let's replace dx with du over 2. Let me just put a line to separate this stuff. Now we need to replace x with something. We need to get rid of all of the x variables and replace them with u variables. So if u is equal to 2x, then x is u divided by 2. So let's put that here. Now notice that we have u over 2 times 2. And the 2's will cancel. So now we have 8 integration du over u square root u squared minus a squared. Now this formula we know it's arcsecant. It's going to be 8 times 1 over a arcsecant u over a plus c. So here's the formula. And now all we need to do is replace a and u. So a is 1. 8 over 1 is just going to be 8. And then arcsecant u over a, or 2x over 1, which is just 2x, plus c. And so this is the solution. Let's work on this example. X divided by the square root of 1 minus x to the 4th dx. So notice that this form is similar to the square root of a squared minus u squared, which is associated with arcsine. So therefore, we want to make a, or a squared, equal to 1. So a is 1. And we want to make u squared equal to x to the 4th. So u is going to be x squared. You got to take the square root of both sides. The square root of x to the 4th is x squared. You divide the exponent by 2. Now, if u is x squared, then that means that du is going to be 2x times dx. And now let's solve for dx. That's du over 2x. And let's also solve for x. Well, actually, we don't need to, because we can cancel it. So let's leave the x on top. Let's replace 1 with a squared, and x to the 4th with u squared, and then dx with du over 2x. So fortunately, the x variable will cancel. And let's take this 2, let's move it to the front. So it's going to be 1/2 in the front. Integration du divided by the square root of a squared minus u squared, which we know this formula to be arcsine. So this is equal to 1/2 arcsine u over a plus c. Now let's replace u and a. So u is equal to x squared, and a is 1. So x squared over 1 is just x squared. And so here's the final answer. 1/2 arcsine x squared plus c. Here's the next one. X divided by x to the 4th plus 36 dx. So this equation has the form u squared plus a squared, or just a squared plus u squared. The order really doesn't matter. So we know that's associated with arctan. So let's set u squared equal to x to the 4th, which means u is x squared, and du is 2x dx. So solving for dx, that's going to be du over 2x. Now we can see that a squared is equal to 36. And the square root of 36 is 6, so that's a. Now, because we have the 2x on the bottom, we don't need to replace the x on top. So for now, let's keep it. Let's replace x to the fourth with u squared, 36 with a squared, and dx with du over 2x. So let's get rid of the x, and let's take the constant 2 and move to the front. So this is going to be 1/2 antiderivative du divided by a squared plus u squared, which is the inverse tangent formula. And so that part in red is equal to 1 over a arctan u over a plus c. Now the last thing we need to do, as we've been doing before, is we need to replace a and u. So a is 6, and u is basically x squared. So we can write the final answer as 1 over 12. 2 times 6 is 12. Arctan x squared over 6 plus c. And so here's the final answer. Let's work on the next problem. X cubed over x squared plus 1 times dx. So what can we do for this problem? Or what should we do? It looks like an arctan problem, but we have an x cubed. If we make u squared equal to x squared and u equal to x, du is just going to be dx. And that's not going to help us to get rid of the x cubed. So we're going to have to do something else. Now, because the degree of the numerator is significantly higher than that of the denominator, let's use long division. So let's put this on the bottom, or outside, and let's put x cubed, the numerator, on the inside. X cubed divided by x squared is x. And now we need to subtract. So now we got to multiply x and x squared. That's going to give us the same thing, x cubed. And x times 1 is x. So let's subtract. X cubed minus x cubed is 0. 0x minus x is negative x. And we can't divide negative x by x squared. So negative x is the remainder. So this fraction is equivalent to what we have on top, x minus x, which is the remainder, divided by what you try to divide it by, x squared plus 1, dx. Now, in this form, we can integrate it. So let's separate it into two problems. The antiderivative of x and the antiderivative of x over x squared plus 1 dx. Now, this part is straightforward. That's just going to be x squared over 2. But we'll deal with that later. Let's focus on this one, because it's a u-substitution problem. U, we're going to make it equal to x squared plus 1. Du is going to be 2x dx, and dx is du over 2x. So let's replace x squared plus 1 with u, and dx with du over 2x. So we can get rid of the x. So this is 1/2 integration 1 over u du. Now the antiderivative of 1 over u, it's the natural log of u times 1/2 plus c. So let's make some space. So now we can replace ln u with x squared plus 1. So the final answer, so the integration of x dx is going to be x squared over 2, and the antiderivative of this stuff is going to be minus, because we have the negative sign, 1/2 ln x squared plus 1. Now we don't really need the absolute value, because x squared plus 1 will always be positive. And then plus c. So that's it for this problem. What is the antiderivative of e to the 3x divided by 9 plus e to the 6x? So what can we do in this problem? Notice that we can square root 9 and e to the 6x. So we can put it in the form a squared plus u squared. So let's make a squared equal to 9, which means a is 3. And u squared, let's make it equal to e to the 6x. So if we take the square root of both sides, we need to divide the exponent by 2. 2 divided by 2 is 1. 6x divided by 2 is 3x. So u is 3x. du is going to be the derivative of e to the 3x, which is the same thing, e to the 3x, times the derivative of 3x, which is 3, times dx. So now let's solve for dx. dx is equal to du divided by 3 e to the 3x. 9 is a squared, and let's replace e to the 6x with u squared. And let's replace dx with du divided by 3 e to the 3x. So we can cancel e to the 3x. And now let's take this constant and move it to the front. So that's going to be 1 over 3 integration du a squared plus u squared, which we know it's the arctangent formula, which is 1 over a arctan u over a plus c. And now let's replace a with 3, and let's replace u with e to the 3x. So therefore, the final answer is 1 over 9 arctan e to the 3x divided by 3 plus c. As you can see, I'm always running out of space. Hopefully this makes sense. Let's move on to the next one. Integration of x minus 3 over x squared plus 1 dx. So what can we do in this problem? X squared plus 1 looks like an arctan problem. If we make u squared equal to x squared and u equal to x, du is going to be equal to dx. And that's not going to help us get rid of this. So therefore, we need to do something else. In this particular problem, we need to split it into two integrals. X over x squared plus 1, which we can use u-substitution to get the answer. And negative 3 over x squared plus 1 dx. So let's start with this one. Let's make u equal to x squared plus 1. So du is 2x dx, and dx is du over 2x. So let's replace x squared plus 1 with u, and dx with du over 2x. And this will cancel, so we're going to have 1/2 in front, integration 1 over u du, which is 1/2 ln u plus c, and u is basically x squared plus 1. So it's 1/2 ln x squared plus 1. Now, let's move on to this problem. So we can make u squared equal to x squared, which means u is x. A squared is 1, so a is 1. And du is dx. Now let's move the 3 to the front. Let's replace dx with du and x squared with u squared. 1 is going to be a squared. So here, this is going to be the arctan formula, which is 1 over a arctan u over a plus c. Now we can replace a with 1 and u with x, so it's just going to be negative 3 arctan x. And then we have 1/2 ln x squared plus 1. Now we don't have to write plus c twice, just once. So this is the final solution. 1/2 ln x plus 1 minus 3 arctan x plus c. What can we do to find the antiderivative of this problem? dx divided by x squared minus 4x plus 7. So what do you think we should do? In this problem, we need to complete the square. And to do so, take half of 4. That is the coefficient in front of x. Half of 4 is 2, and you want to square it. Now, 2 squared is 4. So because we added 4, we need to subtract by 4, so that the value of the denominator remains the same. So now we can factor this perfect square trinomial. And you could literally see what it's going to be. So it's going to be x minus whatever that sign is. So it's minus, and then this number squared. So it's x minus 2 squared. If you FOIL x minus 2 times x minus 2, you're going to get x squared minus 4x plus 4. And then 7 minus 4 is 3. So this is what we now have. Now notice that this expression is associated with the inverse or the arctan formula. So let's make a squared equal to 3. So a is the square root of 3. U is going to be x minus 2, which means du is equal to dx. So we're going to have du, and then x minus 2 squared is u squared, 3 is a squared. And this is equal to arctan, well, 1 over a, arctan u over a plus c. A is root 3, so it's 1 over root 3 arctan, and then u is x minus 2. So x minus 2 divided by root 3 plus c. And this is the solution. Let's try another problem. Let's find the integration of dx divided by x to the 4th plus 2x squared plus 2. Actually, let's put an x on top as well. So feel free to try this one. So this is another problem in which we're going to have to complete the square. The middle term is 2x squared. So we need to take half of the coefficient of the middle term. Half of 2 is 1, and square it. Now, because we added 1, we need to subtract by 1. X to the 4th plus 2x squared plus 1 you can factor as x squared plus 1 times x squared plus 1, or simply x squared plus 1 squared. And then we have 2 minus 1, which is simply positive 1. So now we can make a squared equal to 1, which means a is 1. U is going to be x squared plus 1, which means that du is 2x dx. And in this problem, we need to solve for dx, which is going to be du divided by 2x. So we have x on top, u squared plus a squared, and then dx is du over 2x. So now let's cancel x, and let's take the 2, and we're going to move it to the front. So what we have is 1/2 antiderivative du over a squared plus u squared, which we know it's equal to arctan. So that's 1/2 times 1 over a arctan u over a plus c. So a is 1, so this is just going to be 2 times 1 is just 2. And then arctan u is x squared plus 1. So this is the final answer. So let's work on a different example. 2x divided by x squared plus 6x plus 13. So this is another completing the square problem, but it's slightly different. Half of 6 is 3. So we're going to have x squared plus 6x plus 3 squared. Now 3 squared is equal to 9. So if we're going to add 9, we need to subtract by 9. Now let's factor x squared plus 6x plus 9. Two numbers that multiply to 9 but add to 6 are 3 and 3. So it's going to be x plus 3 times x plus 3, or simply x plus 3 squared. And 13 minus 9 is 4. So now it's in the form in which we can use the arctan formula. So a squared is 4, which means a is equal to 2. U squared is x plus 3 squared, so u is x plus 3, which means du is equal to dx. Now notice that we have an x on top. So we can't just use arctangent yet. Because we have an x on top, and we need to convert it to a u variable, we need to solve for x. If u is equal to x plus 3, then u minus 3 is equal to x. So let's replace x with u minus 3. X plus 3 squared is going to be u squared. 4 is a squared. And dx is just du. So if we distribute the 2, this is going to be 2u minus 6 on top. So now what we need to do is separate the expression into two smaller fractions. So we're going to divide 2u by u squared plus a squared, and separately we're going to divide negative 6 by u squared plus a squared as well. So let's clear away a few things. So this is going to be 2u over u squared plus a squared du minus 6 du over u squared plus a squared. So now let's focus on the integral on the left. We can use another u-substitution, but because we used the u variable already, let's use a different letter. Let's use z. So let's set z equal to u squared plus a squared. The reason why we want to do that is because dz is going to equal 2u times du. And this 2u can cancel with the one on top. So solving for du, it's going to be dz over 2u. So now let's replace a few things. So we have 2u divided by z and du is dz over 2u, which means these cancel. So the antiderivative of 1 over z dz is the natural log of z. And now we know what z is equal to. Z is equal to u squared plus a squared. So this is going to be the natural log of u squared plus a squared. And u is x plus 3. So that's going to be ln x plus 3 squared plus a squared. And a is 2, so a squared is 4. Now, notice that we had this x plus 3 squared plus 4. If we FOIL it, x plus 3 times x plus 3, that's x squared plus 6x plus 9. And if you add 4 to that, it's going to equal the original denominator, which was x squared plus 6x plus 13. So we want to write it in a way that's similar to the original expression. So this is the integration or the antiderivative of the first part of our problem. Now let's focus on the second part. Now we could just use the arctan formula because that's what we have here. So it's just negative 6 times 1 over a, where a is 2, arctan u over a. In this case, u is x plus 3, and a is 2, and then plus c. So I'm going to write it here. So 6 divided by 2 is 3, but that's going to be negative 3. Arctan x plus 3 divided by 2 plus the constant c. So this entire thing is the answer. Calculate the antiderivative of x divided by the square root of 9 plus 8x squared minus x to the 4th dx. Go ahead and try that one. So this is another completing the square problem. But this time we have a negative sign in front of the leading term. So it's not going to be an arctan problem, but it could be an arcsine. So what we're going to do is take out a negative. So it's going to be positive x to the 4th, but negative x squared. And now let's complete the square. Half of 8 is 4. And we need to square it. Now, we've added 4 squared times negative 1 if you distribute it. So we've added negative 16. To undo that, we need to add positive 16. Now let's combine like terms. 9 plus 16 is another perfect square. It's 25. And to factor this expression, it's going to be half of this exponent, x squared, minus this number before you square it, minus 4 squared. If you FOIL x squared minus 4 times x squared minus 4, you're going to get x to the 4th minus 8x squared plus 16. On top, we still have an x, and there's still a dx. So we can see that a squared is 25, which means a is 5. U is x squared minus 4. Du is 2x dx. So dx is du over 2x. So now let's substitute. Let's replace 25 with a squared. And since u is x squared minus 4, x squared minus 4 squared is u squared. And dx, let's replace that with du divided by 2x. So let's cancel an x, and let's take the constant and move it to the front. So what we now have is 1/2 du divided by the square root of a squared minus u squared. Now this is the formula of arcsine. So what we have is 1/2 arcsine u over a plus c. So now let's replace u with x squared minus 4 and a with 5. So the answer for this problem is 1 divided by 2 arcsine x squared minus 4 over 5 plus c. And that concludes this problem. Now let's work on a definite integral problem. So go ahead and try this one. Now, as we can see, the setup is associated with an arctan problem. We can clearly see that a squared is 25, which means a is 5. And u has to be x minus 3, which means du is equal to dx. So let's replace 25 with a squared and x minus 3 squared with u squared, and dx with du. So as soon as we change the x variables with u variables, we need to change the values 3 and 6. So what we're going to do is plug in those numbers and find u. So using equation u equals x minus 3, when x is 3, u is 0. So let's put that on the bottom. And when x is 6, u is 3. So if u is x minus 3, simply decrease each of these values by 3. Now the antiderivative of du over a squared plus u squared is 1 over a arctan u over a plus c. Now if we replace u with x minus 3, we're going to have to use these numbers again. But if we don't replace u with x minus 3, we could use 0 and 3 instead of 3 and 6. So I'm not going to replace u with x minus 3. I'm going to keep it as u. However, I do need to replace a with 5. So I have 1 over 5 arctan u over 5. Now, when you're dealing with a definite integral, you don't really need the plus c, because you have to plug in 0 and 3. So you don't need the constant. You only need it when you're dealing with indefinite integrals. So this is going to be 1 over 5 arctan 3 over 5. We need to plug in the top number first, minus the bottom one, arctan 0 over 5. Now, arctan of 0 is 0. So this simply disappears. So it's 1 over 5 arctan 3 over 5. And you could type it in your calculator. Make sure it's in radian mode. And this is equal to 0.108, which is the answer. So that's it.